Hey everyone, so today we're going to be performing TG-51, absolute reference clinical dosimetry. Today we're only going to be shooting for photons on our edge machine. Our edge machine is calibrated to deliver 1 centigrade per monitor unit at 100 SSD for a field size of 10 by 10. So this is the equipment that we're going to be using. We have our IBA tank, which is currently filled with water. We have our barometer, which also will be measuring our temperature and pressure for our temperature and pressure correction factors. We have our TG-51 ionization chamber, which is a N313 chamber, zero point 0.6 cc's. And we also have our electrometer here. Now, one thing to note, if your electrometer and your ion chamber are sent out as a unit, your P-elect will be 1. If not, then essentially you'll be using the P-elect that is listed on your electrometer. One thing to note about the electrometer is if you set your bias to minus 100 or plus 100, that essentially means that you're at full collection for plus or minus 300 volts. One quick thing to do is to ensure that you set it to the correct voltage. You can also do a check bias, which essentially will tell you what bias that you're set at. Let's begin. So now we're going to go ahead and attach our front pointer accessory to the head of the gantry here. Make sure it's snapped in so that your lights are green. That means that it's securely in place. Then our front pointer here, we're going to attach. For this, we're going to turn the room lights back on so we can look at the scale. Okay.
I'm gonna
Yeah.
set this. I think it's gonna need
Mhm.
a tiny bit. Yeah.
Mhm.
Oh, that's actually pretty good.
Yeah.
That's weird because we didn't set it. Oh, you
Mhm.
set it with lasers.
Yeah.
All right.
Uh, Now we're going to take our front pointer off. We're going to wipe it, and then we're going to do it one. Oh, you didn't want to do it that? Oh, okay. There's like a two-way method that John showed us. Like you set it first, just so that that little tension, that surface tension gets released, and then we put it back in a second time. And then when we see that there's not that much surface tension, then we know that it's confirmed at 100. But that's not important, I guess. Yeah. All right. Let's go do it quick. So then
What's that?
now, oh, still shooting. Oh, okay. So now, now that we have confirmed our ODI, I'm sorry. Now that we confirmed our front pointer is actually at 100 SSD for the water surface, now we just want to make sure that the sensitive volume of the chamber is actually at the crosshairs of the gantry. So we'll go ahead, we'll turn off the lights, we'll turn on the gantry lights here. A trick that you can do is you can use a piece of white paper, position it under your tank, and then look at the shadow of the ion chamber and the crosshairs. That essentially will help you to position your ion chamber into place. Turn our lasers off now. And what we'll do is we'll also float the couch if need be. Okay. All right. So now we're gonna go in and out. Okay. And now we should be ready to shoot.
Needs to come in.
Yeah. Come. Yeah, I can't see it that well. I usually use like that white piece.
Got it.
Uh, let's see.
So it's currently like
Yeah,
almost to the tip.
like right up to the
Almost to
tip. Yeah. All right. So I guess that's a video we're edit.
We're not doing any editing. We're just rolling with it. This is real life. Yep. You've got it right on the tip. You want it in the center. There we go. Hey, that's not bad. That's
All
pretty
right.
good. That's pretty good. A little bit left and right.
Now make sure left and right is good.
Nope.
Yeah.
I got a good view from here.
Mhm.
It's pretty only good. Alright, I'll just push it towards me a little
Mhm.
bit. Alright.
All right. Now the table's locked. Also looking for symmetry. If you look at from the tank from this side, if you see that there's a full circle, that also means that it's symmetrical and it's actually at the center of the sensitive volume of the chamber is at 100 SSD.
Let's go to 10.
All right. So now let's drop our ion chamber to a depth of 10 cm. In order to do so, you have your controller here. So we already set our origin to 100. The way that you can do that is you go to basic setup, you'll hit enter, you'll also hit enter again to set origin, and then the value you will store as your user origin. Now, it states that it's at an actual depth of 0000. So that means that it's set at our origin. So now, let's drop it 10 cm. We'll exit origin setup. Now we'll go to direct move, hit enter. Oh, numerical.
Yeah, we made that mistake once already today.
We'll go to numerical input. And then now we'll set to a depth of 10 cm.
I think that should be positive. I hope I'm right
And you are correct.
there.
So that's one mistake that you also can take note of that you can make. So our depth should be a positive increase from your zero origin to 10 cm, which is 100 millimeters. Hmm. Now, we're going to use this particular instrument to confirm that the ion chamber is at a depth of 10 cm. Hmm. Right? So we confirmed that our ion chamber is at a depth of 10. Our water surface is at 100 SSD. Now, one thing we want to do is, since our water has been in this tank for some time and has stabilized, we can go ahead and take temperature and pressure. So now we're going to go ahead and warm up our edge. And so we're going to set 100, actually to 1,000 monitor units. We're going to shoot a 6x beam. We're going to max dose rate of 600. And we're also going to set our jaws to a 10 by 10 field size. We're going to hit go to. If you look at this screen, essentially you see that your jaws are moving. And now we're going to hit prepare. And then when the MV ready light illuminates, then we're going to hold that for approximately 1 or 2 seconds and then hit MV beam on.
This is going to take a long time, so I'm just going to stop
Yep.
it.
So in the essence of time, we're going to hit beam off because I think we warmed up our edge for 6x beam good enough. And then now we're going to get ready to actually do TG-51. So our field size is set at 10 by 10. Our electrometer is set to the correct bias, which is minus 100, which is actually minus 300 volts. And now we're going to beam on. So we're going to take an average of 3 raw readings. And so, all right, so we're going to load our first energy. We have our 6X that's loaded. We are going to set 100 monitor units, max dose rate, and also a field size of 10 by 10. One thing on the electrometer to take a note of, we're going to set our bias to minus 100, which is technically minus 300 volts. You can adjust the sensitivity in order for you to get additional sig figs. And each time you take a reading, you can hit the 0 check to clear and start over. If you're uncertain of what bias it's set to, you can scroll to the right where it says bias check, and essentially that'll tell you what the actual bias is set to. Now, you've hit prepare. Now we're ready to shoot. We're going to take an average of 3 readings for our M minus raw. All right. So now we have our average of 3 readings for our M minus raw. Now we're going to change our bias to plus 100 so that we can get our plus 300 volt readings.
Oh, you get that crap out of the way? No, it's fine.
All right. So now we've been able to collect our M plus raw and our M minus raw reading. And now, as TG-51 recommends, we're going to drop our bias to 50% of M minus raw, because M minus raw is what was used for us to set up our calibration for our machine. Still going to shoot 100 MUs and still going to be a 10 by 10 field size. All right. So now, all right. So now we have our Excel spreadsheet loaded. Essentially, we're going to enter the values. So this was our temperature and pressure that we recorded at our treatment machine. So we're going to enter those values in, which we already done. And now that we have all of our raw readings, you can essentially start to see any trends in our for our MUs. Let's see here. So a couple of things about our spreadsheet. We have our absorbed dose to water calibration factor, which we've documented here. Our P-elect, which we have documented here. Our percentage depth dose, 10 with contamination and 10x, X-ray only without contamination. We're not too concerned about this since we are taking measurements at a 10 cm depth for photon energies. And as you can see here, we're now tracking to be 0.26% high than what we've actually calibrated. And so this it will need to be adjusted. So in order for us to adjust, we're going to go into service mode and we're going to go into access and we're going to actually input 1.26 as our new value because it's essentially our machine. This is what we're telling our machine is. All right. So in order for us to now adjust our MUs, we're going to go to beam tuning. And in the beam tuning tab here, we stated that our machine was 0.263% high. And so what we want to do is we want to set our standard MUs to be 100.263. So instead of going to 3 sig figs, we'll just use 2. And the reason why we're doing 100.26 is essentially because we know that our machine is calibrated for 100 MUs to equal to 100 centigrade. So now we're going to hit calibrate. Now notice that you get an invalid dose cal result. Try again. This pops up because you have not run a beam. So in order for you to be able to change or edit any of the MU values here, you need to have a beam that has been ran. So now what we'll do is we'll go ahead, hit prepare, shoot our beam, and then now we'll also be able to change it. One thing that you should be mindful of is that since our last measurement taken was at 50% of the bias, we'll go ahead and make sure that we change it to back to minus 100, which is 300 volts. All right, so now you can hit calibrate, and now you see dose cal recommended settings. Now we're able to go ahead and change these values. So we're going to click yes. All right. So now our settings have been saved, and now we can go ahead and measure once more. So we're going to take 3 more measurements. All right. And we're going to go ahead and record those measurements. Mhm. All right, we're going to go ahead and shoot our final. All right. So now our MU adjust now has reflected that we're now within a 0.700 of a percent difference, which essentially is as close to 0 as we will probably get.